All right. So for today's lesson, I wanted to establish some rules for drawing. And these are rules I would use when I would be drawing with a pencil and paper and a compass. And I'm going to carry those over into AutoCAD too. So, and we have some math formulas that we'll use too, and I've got them up on the screen here. So we'll use Pythagorean theorem a little bit. We'll actually be drawing our triangles, so we won't actually have to do very many calculations with that. But we will be using that concept to figure out travels and hypotenuses of triangles as we draw stuff. We'll definitely be drawing a lot of round stuff and a lot of other shapes to round, whether it's squares or rectangles to round. And so we'll need to know our circumference formula, which is pi times the diameter. And a lot of times I'll use 3.1416 for pi. I'll round a lot of my figures to 4 decimal places. And then, in relation to that is when I'm starting to build stuff. The circumference of a circle is a great principle to use when we're just talking about paper or things that don't have thickness to them. But once we start dealing with metal, metal always has a thickness associated with it, and we've learned to account for that thickness as we've bent stuff last semester. We'll continue that in how we roll stuff around. We always have to be aware of the thickness of the material we're using. So if I'm shooting, so what I've got here also up on the screen is for my round stretch out figures, which really impact my circumferences and my flat pattern layout. So if the object I'm shooting for to be accurate, I've measured to an ID dimension, an inside diameter dimension, or an inside dimension. To figure the stretch out of that, we actually take that ID dimension. We would add one metal thickness with whatever the thickness of the material is I'm using, and then we do that figure first. So we take the ID, add a metal thickness, and then multiply by pi. And that will give us our stretch out. As I roll that thing round, it will come to match the ID that I measured. So it's just the reverse if I'm measuring to an outside diameter. So if something that I'm looking to match or make, and I'm being critical to the outside dimension, the OD, I would take that OD dimension that I've measured, or that I'm trying to shoot for, I would subtract one metal thickness, and then I would times by pi. And that would give me the stretch out of my flat pattern size. So we'll use that figure as we draw stuff to match a certain pipe diameters, pipe schedules, or just figures in our problems that we use. I usually sometimes factor in working with our metal thicknesses. So I just wanted those up on the screen, and for you to have as a reference and a review. But these are, and if there's any more, I'll add them to the lessons as we go along. Those are ones that pop off the top of my head that I know we'll use. And then what I want to also do in this video is establish a couple rules and how I draw and set things up. And I've got like 4 rules here. I'm going to start with dividing a circle. So this is going to be just a real common thing that we use. And what I'm going to do, let me draw 2 views of just a circle with really no thickness, I guess. I'm going to draw like a plan view and maybe a top view and a plan view here. And so what I'm going to do is draw this circle. Maybe I'll change to green. And maybe I'll draw like a 4-inch diameter circle. Let me move that just a little bit. Just move it off my instructions here just a little bit. Okay, so there's my circle let me draw the kind of the elevation view of what that circle would look like if I turn that and looked at it from. So that's kind of a top view of a circle. I'm going to look at it from an elevation view, and so that's just going to look like a line, you know. And when I do this, let me load my lines. I'm going to load a nice dashed line that I use for projection lines. I like this one. So I'm going to load that up. Let me cancel that. Let me OK that. Because I'm just going to project this down, do a quick drawing of a circle, and project this down just as if I was drawing on a board. Just project these down so that I can get me another view of my circle. So I'll just use this point and come in parallel. Yeah. And so I'll just tuck this in now that I've established this is where. So this, what I've just drawn in here is just a top view of a circle and an elevation, kind of a plan view of my circle here, which has really no thickness. It's just kind of a flat circle. And I like to do this because we use this setup a lot when we draw. I use this, you know, when we turn circles into this view, into kind of a front view here, an elevation view, it just looks flat like that. But it still has its depth to it. It still is like, you know, going away from me in this view as a circle. So, and what I want to show you here is we're going to use a common division to divide my circle. And these, when I divide my circle, these are just for reference lines. They are established to pick up information on an object that I draw. So they really aren't part of the object. They are reference material that I use to develop a flat pattern. So I could really divide this into any number of segments. We're going to use the number 12 on a full circle to divide this, and I'm going to divide this and label this. So to divide a circle, I'm going to change this to white. So if I change to white, sometimes I can see the node points. When I divide this, it's going to establish some node points, and what that is it's something I can snap to on that circle. So I have to be able to select that on my menu, which is maybe right here. It gives me my options of what I can snap to, that I can toggle on and off. One of those is a node point, which when I divide the circle, it's going to establish these nodes to snap to. So I'm going to make sure that I have that selected so that I have that as an option to snap to. And I use this ribbon menu a lot. So here's my divide. You could type in divide also, but I'm going to divide this circle, and then ask me the number of segments I'm going to divide into. It's going to be 12, and I'm going to say enter. And where I've had this a different color, you can kind of see these node points appear, and I'll actually start to label them now. But the reason why we use 12 is kind of, and I was talking about this with Malcolm, and the reason why we use 12, like I said, it could be any number, but it goes back to the use of a compass. And when we would draw a circle, we would set a compass to the radius, you know, and draw this circle from the center. And then when I have that compass already set to that radius, if I just go to the quarter marks, the outside, you know, the quarter marks of this circle, and then use that same radius, and from the quarter marks, so what it would do is, let me just show you, it would be, if I take like maybe a line here, I'm going to snap. So this is like a quarter mark on the circle here. So if I would have used a compass to draw this circle, I would have set the pointed here down, drawn this circle. Then I would still have my compass set at this radius, and I could actually bring that compass point out to this edge, and I could set it down. And then if I would kind of like scribe a mark across the circle, it would end up being right here where this node point is, set with the same radius. So it would establish that point, then I could swing it down here and establish that point, and then I could like come to this quarter mark and swing it and establish this node point and this node point. So it was a quick way in drawing to just to divide a circle, and it ended up being it divided it into 12 equal segments around this. So this just kind of goes back to using a compass. The reason why we use this figure, I could divide it any number of ways, and it really affects, you know, the accuracy of my pattern, how close my divisions are. But what we're going to do a lot is you'll see me use that 12 figure, and so I've just, and that's what I've done. I've divided this by 12. So let me show you where those are, and I will actually I'm going to bring those down. Well, how do I want to do this? I think I just want to like label these node points. So just so we can see, and this is going to be node point 1. Yeah, I do want to save it. So that's node point 1. I'm going to like snap to this node point and bring it out here, and I'm going to call it number 2. And I've got this node point down here. I'm just going to repeat this for labeling purposes. This one is node point 3. This one will be 4. And on around here, there's another one. If I pick up here, let me just pick up my leader again. That one right there, missing it. That's node point 5. I can bring that in just a little bit. This one ends up being number 6. And then I come up and around this way, so I'm just kind of going counterclockwise. This is on the quarter mark also. That's picking up the node and the quarter mark of the circle. And that's going to be node point 7. Let's do number 8. Let's do number 9. There's 10, 8, 9, 10. Just have a couple more here to pick out this one. 11. And I think there's just one more right here. 12. So all I've done is just labeled all these node points now. So that shows that I have divided this into, and I've established 12 node points along here. So that means in between each of these that I'm pointing to is the same distance around the circle. So it's kind of equally divided that. Now if I were to, this is what I kind of want to show by doing this. If I were to use my orthographic projection lines down to this representation of the circle, which I will do here. I'm going to use my dashed line. So when I do this, here's point 1. If I bring this one down, what I'm actually going to do is I'm going to start on this side of the circle and bring these across. You'll see that, like in this case, as I come down and to be perpendicular to the line here, that points 12 and 2 on that circle line up. And I'm going to do this again off of this point 11. 11 and 3 will now line up. Alright. Let me keep going around here. I'm going to go 10 is going to line up with 4 in this view. Nine and 5 are going to line up. 8 and 6. And then number 7 comes down as the end of my line. So what I kind of get here now is I've crossed my lines a little bit, and I like to keep things kind of clean. But Now if I were to kind of like label these lines down below, if I take the same thing, this point here in this view is still just 0.7. And this is more of an exercise for your own visual. I just want to make sure you guys can see where I'm going with this here. So this point, if I look at it in this view, is just 0.7, just the outside edge of a circle. If I give this point a name on this in this view, this would actually be point 6 and 8. So I could actually label this like 6 and 8. Because really in this view, those two line up with each other, 6 and 8. So it actually does have two names in this view here. And if I continue this around, then I'm going to name this one 5 and 9. Let me clean that up. And this one becomes 4 and 10. Good. 4 and 10. I've got 3 and 11 for the next one. And this may not make a lot of sense now, but we're going to use this over and over again. And like for a little while, I'll label my points so that we can kind of build that visual. And then as I continue to draw, that becomes really automatic to me. I get to where I can just view that this point down here in this view, I just know it has 2 points on that circle. So this is 3 and 11. Okay. And my last one that shares points is 2 and 12. Yeah, right here. So we'll say 2, 12. And the last one that's by itself is where I started. So I'll just come up here and call it number 1. So now I've just, let me see if I can position this a little more in the center here. To divide a circle, I've just been able to divide this circle into 12 equal spaces and then bring those down to an elevation or front view and designate the same point on the circle in a front view. So that just becomes, we're going to do that a lot, and it's going to become really automatic for us. So I just want to take the time to really explain, when I'm working with circles, I'm working with these points as I change views that line up on top of each other. So a lot of times what I do as a shorthand to represent this activity that's going on, I can take what I can do to kind of quickly represent that in a drawing that I'm doing. I'll just show you how I do that. Maybe I would just start with that front view line. So I'm just going to draw over to the side here, and I'll just come in parallel with this. This was a 4-inch diameter circle, so I'm just going to make a 4-inch line. Okay. And what I do, and maybe my drawing would be kind of up on the top side of that line in the Y direction here is where I'd actually draw what I'm going to draw. Maybe it's a 4-inch pipe or something. So I put my reference material down below it, and I kind of use this in a shorthand way. And so what I do is I will tend to do these with dash lines. Anything that's kind of reference material or projection lines, I use dash lines a lot. And I would take like a circle like this and snap it to this line here. And then I'd actually use my trim command to get rid of half of that circle. And then I'm just dealing kind of this half circle that in this half circle, I'm going to put all this information in it really quickly and easily. And to do that, and to show maybe my nodes, I'll change my color before I divide this. I just take this semicircle and I divide it by 6. Just kind of half. It's just half a circle. My full circles are divided by 12. But when I come down into a plan view, an elevation front view, I guess, is it becomes really only 6 spacings because 2 of them line up. And so I can just do that easy shorthand here and get these 6 spacings. And then what I do is I use, a lot of times when I go to do this, I'll start using lines, but I'll bring this up to here. And these are my node points. Just snapping these perpendicular to that line that I drew. It's establishing those points kind of quickly and easily, and actually out of the way of my drawing. And the reason we do this is because we want the equal spacings of something that's round. If I'm going to draw this as a 4-inch pipe up and away, I just kind of want my information to be equally spaced around that circle. But when I look at that in a front view, like I've done over here, the spacings aren't equal in this because they are representing something that's going away from me or coming towards me. And so in that front view, the spacings look all different. Yet in my top view, they are equally spaced. And so I have the same thing going on here, only kind of just a shorthand way that, here is my point 1, here's my point 212, here's my point 311, 410, 59, 68, and 7 over here last. So I get the same like equal spacing projected up to the line, and this just allows me to keep the information that I'm going to pull off something round equally spaced, but represented in that kind of that front view, that elevation view. So if it's a little foggy here, that's okay. We're gonna continue to use this principle, and I think that'll be the end of this video, and I'll make some videos for the other rules that I'll set up. So, but yeah, if it doesn't make sense, you'll start to see this played out in our drawings right away as we take off and draw. And so I think through practice this will become pretty automatic, and I just want to take the time to really explain this here. So we'll catch you in the next video when we talk about dividing a line and bisecting a line and bisecting an angle. So stay tuned for that.